In lecture question 5 of partial derivation, we consider a function g of three variables x, y, and z. And in this case, we also say that x and y are also functions of z. And what we want is a total derivative dg by dz. So we need to calculate the derivative of g according to z, taking into account the fact that both x and y are also functions of z. So we will have eventually to include the derivative of x according to z and the derivative of y according to z. So first, just consider the part of g which is just a function of z. So that's if we don't take into account for the moment the fact that x and y are function of z, that's just the partial derivative of g according to z. So we have this term. But now we need to consider the fact that there is also a dependence of z in x and a dependence of z in y. So the dependence of z in x is encoded in the partial derivative, in the total derivative dx over dz. But we need to know how g varies with x, and that's encoded by the partial derivative dg over dx. And of course we have the same term for y. So we take an example of that in lecture question 6, where we have g of x, y, and t, and which is expressed as. And we also say that y itself is a function of t, it's a cosine. And but x is not a function of t. So if we just apply what we did in lecture question 5, but replacing z by t, we can directly express dg over dt. So the first term will be the partial derivative of g according to t. In this case, it's minus 3. The second term, in our case, is 0 because x doesn't depend on t. So the third term we have to calculate the partial derivative of g according to y. So that's only 1 in this case. And we multiply by the derivative of y according to time, which will be minus sine t.